How rotate your Android phone mid-navigation? Backstack wiped, UI state gone. The user has to start over. Now kill the process and reopen the app. Same thing. This is the silent tax of writing navigation with view models, save state handles, and backstack managers that were never designed to cross platforms. In this episode, we solve all of that in one move. Decompose is a navigation library that makes the backstack a serializable value, makes component lifecycle multi-platform, and handles configuration changes, process depth, and iOS in the same model. No duplicated navigation code on Android and iOS. No bundle dance. No where did my state go on Android and iOS. No bundle dance. No where did my state go bugs at 2 in the morning. We are looking at the exact navigation setup inside MyEuroStatApp, a production Kotlin multi-platform app shipping real Eurostat data on both platforms. Every file we touch exists in the repository right now. Let's go! Before we write a line, the honest question, why not AndroidX Navigation? It works, it has Compose support, the documentation is extensive. 3 showstoppers for a multi-platform project. First, AndroidX Navigation is Android only. The moment you try to share it with iOS, you cannot. You would write 2 completely separate navigation implementations and keep them in sync forever. That is not sharing code, that is just having 2 code bases. Second, the state holder in AndroidX Navigation is ViewModel, which relies on Android's ViewModel store. Multi-platform code cannot use ViewModel store. Third, backstack serialization in AndroidX Navigation ties you to Android bundles. Again, Android only, Decompose solves all 3. The backstack is a typed, serializable Kotlin structure. The lifecycle is from the SNT library, which has the same API on every target. The state holder is called a component, and it compiles to commonMain. One implementation, every platform. In AndroidX Navigation, your navigation graph lives in XML or in a nav host composable with string routes. With Decompose, your graph is a sealed interface in Kotlin. Open ChildConfig.kt in core navigation. Sealed interface ChildConfig and then 10 data objects: home, population, economy, environment, trade, transport, tourism, social, science, settings. Every destination is a type. Everyone is annotated with serializable from Kotlin's serialization. Why serializable? Because Decompose persists the entire backstack across process depth by writing it to a bundle using the serializer you provide. Annotate the config, provide the serializer to ChildStack, and backstack restoration is automatic. If a destination needs a parameter, say detail with an ID, you use a data class instead of a data object. The type system forces you to handle every case when you consume the config. You cannot accidentally navigate to a destination that does not exist. Now open RootComponent.kt. The interface exposes one property, stack, which is of type value wrapping ChildStack, and 2 methods, onTabSelected and onBack. Default root component delegates, component context by component context by component context using Kotlin interface delegation. This is how the component gains lifecycle, state keeper, backhandler, all the S20 primitives, without inheriting from anything. Inside, stack navigation is the imperative navigator. You call bring to front to show a destination, pop to go back. The ChildStack call is where navigation becomes declarative. You pass the navigation source, the serializer, the initial configuration, handle back button true, and the child factory. The result is a value of ChildStack. Whenever the stack changes, subscribers see the new value. The child factory maps each child config to a component instance. Home is special, it has no component, it returns unit because the home screen is pure UI driven by no state machine. Every other destination fetches a component factory from Koin by qualified name. Open rootComponentFactory.kt in Compose App Native App Main. This function runs once at startup on both platforms. It fetches the Koin container, then for each child config class, it resolves a component factory qualified by the class's qualified name. Those factories were registered in each feature's DI module. The component factory is a single method interface. Create that takes a component context and returns a component. The context is not available at DI graph build time. It is created at navigation time when Decompose instantiates the child. This is why we use a factory rather than resolving the component directly. One function, platform agnostic, Android calls it from MainActivity. iOS calls it from MainViewController. They both get back a default root component. The platform difference is only in how they hook into the host lifecycle, retainedComponent on Android, LifecycleRegistry on iOS, and those two lines are the entire platform-specific navigation code for this app. Open MainActivity.kt in Compose App Android Main. 4 lines. Override on create. Call retainedComponent. Passing a lambda that receives a component context and calls create root component. Then call setContent with EurostatApp, passing the root component. Then call setContent with EurostatApp, passing the root. That retainedComponent call is doing a lot. Under the hood, it uses Android's view model mechanism to keep the default root component alive across configuration changes. Rotate the device. The activity is destroyed and recreated, but the component instance is the same object. The backstack is the same, every state flow inside every child component is emitting from the same instance. No state loss. Contrast with a naive approach, creating the root component inside onCreate directly. Rotate the device, activity recreates, new component, backstack lost, active flow subscriptions cancelled and restarted. retainedComponent is a one-line fix for one of Android's oldest pain points, and on iOS we do not need it at all because MyEuroStatApp is not recreated on rotation. Open MainViewController.kt in Compose App iOS main, also 5 lines. Call init create a lifecycleRegistry. Call create component passing a default component context built with that lifecycle. Call lifecycle.resume. Return Compose MyEuroStatApp with EurostatApp lifecycleRegistry is the iOS side lifecycle owner. You control it manually. Calling a resume brings the component to the active state. If you wanted to handle background and foreground transitions, you would call stop and resume from the MyEuroStatApp lifecycle callbacks in Swift. Compose MyEuroStatApp is the Compose multi-platform bridge. It wraps the Compose root in a MyEuroStatApp, so the Swift side of the iOS app can present it as it would any other view controller. From Swift's perspective, this is just a MyEuroStatApp. Everything Compose and Decompose does happens invisibly inside. The root component, the backstack, the child components, identical to Android. The only platform code is these 5 lines. Open EurostatApp.kt. This is the single root composable for both platforms. It wraps everything in Eurostat theme, uses adaptive scaffold, and inside calls children from Decompose's Compose extension. Children takes the stack value and a lambda. For each child in the stack, a value and a lambda. For each child in the stack, it receives the child instance and renders the appropriate composable. The when expression is exhaustive over every possible instance type. Unit for home, population component for population, and so on for all 9 feature modules. When Decompose pushes a new child onto the stack, children automatically shows the new composable. When you pop, it goes back. Transitions can be added per child, animated push and poppable. When you pop, it goes back. Transitions can be added per child. Notice that no composable in this when block knows anything about routing. Population screen takes a component and an on-back lambda, that is its entire surface area with the navigation system. Screens are navigation-agnostic. They consume state and emit intents. Open population component-kt. Default population component delegates. Component context by component context, just like the root. Inside coroutineScope from S&T lifecycle coroutineScope tied to the component's lifecycle. When the component is destroyed because navigation poked it off the stack, the scope is cancelled. Every coroutine inside it, every flow collection, every network request in flight, all cancelled cleanly, no leaks. This is the multi-platform equivalent of Android's view model scope. The difference is that Decompose's coroutineScope works identically on iOS, desktop and WASM because it is built on S&T lifecycle, not Android lifecycle. The mutable state flow holding UI state, the coroutine that collects the repository, flow, the debounced country selection, all live inside this scope. The component is the single source of truth for that screen. When it dies, everything dies with it. When navigation pushes it again, it starts fresh, loading data from cache immediately. Beyond configuration changes, Decompose handles process death. Android kills background apps to reclaim memory. When the user returns, the app must restore to exactly where they left, backstack and all. Decompose does this by serializing the ChildConfig stack using the Kotlin serialization serializer you provided to ChildStack. On Android, the serialized bytes are saved in a bundle by an onSave instance state. On restore, Decompose reads the bundle, deserializes the config stack, and calls ChildFactory to recreate each component. The child components themselves can participate. Each receives a state keeper from its component context. You can save and restore any serializable value across process depth. In population component, the current query, country code, year range would be stored in state keeper so the user lands on the same data slice they left. The sealed child config design makes this safe. Every destination is a known typed serializable value. There are no string routes that can become stale or mistyped. Pull back and look at what Decompose gives you for the price of understanding ChildStack, component context, and LifecycleRegistry. Configuration change survival free via retainedComponent on Android and free by default on iOS. Process death and backstack restoration, free via serializable ChildConfig and the State Keeper API. Multi-platform, the entire navigation model is in commonMain. The only platform-specific code is MainActivity's 4 lines and MainViewController's 5 lines. The component pattern also enforces a clean architecture boundary. Screens cannot call use cases directly, they cannot access repositories, they consume a component interface that exposes a state flow and an onIntent method. Tests inject a fake component, previews inject a fake component. The UI layer is completely decoupled from the data layer by design, not by convention. Compare the alternative, separate navigation stacks per platform, duplicated backstack logic, platform-specific state restoration, no shared lifecycle model. Decompose trades a learning curve for a permanently smaller maintenance surface. Here is the bottom line. Decompose's ChildConfig is your navigation graph in the type system. ChildStack is your backstack as a reactive value. Component context is your multi-platform lifecycle and state keeper. retainedComponent on Android and lifecycleRegistry on iOS are the only platform themes in the entire navigation layer. 4 concepts. 2 platform-specific files. Navigation that survives rotation, process death, and works identically on Android and iOS, written once in commonMain. The MyEuroStatApp repository has every file we discussed open and working right now. Clone it, run the Android debug build, rotate the device mid-navigation, kill and reopen the process. Watch the backstack survive. Then read through component and trace exactly how it happens. The code is short enough to fit on a single screen. If this series is helping you ship real KMP apps, subscribe and ring the bell. Next episode, Compose Multiplatform and the design token system that scales across all 8 feature modules. Subscribe for more on Android AI tooling and Kotlin Multiplatform.